USB drives with malware are deliberately dropped in public locations such as parking lots to entice victims to picking it up and opening it using their computers. Therefore, most of us would never insert a USB drive if we found one. But what if I told you that programmers do something that is much worse every day and it looks something like this? Downloading and installing software with a package management tool like NPM or pip makes your code a target for supply chain attacks. An attack that is, in occurrences, rapidly increasing. An attack that seeks to damage an organization by targeting less secure elements in the supply chain. A supply chain attack can occur in software or hardware and are typically enabling cybercriminals to install malware or hardware-based spying components. This is like a Trojan horse in a modern world. Two well-known supply chain attacks is called typo scoring and dependency confusion. Typo scoring is where you mimic a popular URL or a package name and then rely on a typo from a user or developer, which will then lead them to your site or to download your package. An attack like this happened to a popular Rust crate called Rust Decimal, where the attacker simply removed the underscore from the name and uploaded their own crate called Rust Decimal. If you downloaded the wrong package, you would get a payload which was equipped to capture screenshots and log keystrokes. Dependency confusion is a bit more sophisticated attack, which exploits insecure usage or flaws in the package management tools. This attack also requires you to do some research to find private package names used by company or persons you want to attack. Finding private package names might sound hard, but you'll be surprised to see how easily some of them can be discovered by using the standard inspect tool in your web browser. As an example, let's say you found a private package name for a Python application and then uploaded a public package with the same name to PyPI. And let's also say the developer of said application uses this command. The process for downloading the package would look something like this. 1. Check whether the library exists on the specified internal package index. 2. Check whether the library exists on the public package index, PyPI. 3. Install whichever version is found. If the package exists on both, it defaults to installing from the source with a higher version number. Attacks similar to this was actually tested against multiple large companies like Shopify, Apple, Microsoft, leading to bounties of $100,000. So how can we prevent this? First and most obvious is dependency management training. Install good practices and policies, know what you are downloading or upgrading and why you are doing it. But there's also some work being done to make it easier to verify legit packages. An example of that is Sigstore, where software developers can sign off on what they have built, and anyone can search a transparency log to check that the code they are using has been signed and who has signed it. This tool have working partnership with Google, the Linux Foundation, and Red Hat. Tools like that may save a lot of companies in the future.